200,000. That is the number on the table. By the year 2031, the ambition is to have that many robotaxis operating on the streets. It is a staggering figure. To put that in perspective, that is more than the total number of cars sold by some of the largest automakers in a single year. When you hear a target like this, your mind naturally goes to the software. You think about the algorithms that allow a vehicle to navigate traffic. You think about the artificial intelligence that makes decisions in split seconds. But the reality of this partnership between WeRide and Lenovo suggests something much more industrial. The challenge is not just writing code. The challenge is building the physical world that runs that code. Here is the thing about scaling autonomy. For years, the industry treated self-driving technology as a software problem. The assumption was that once the neural networks were trained, the cars could simply be deployed. But a fleet of 200,000 units does not behave like a software update. It behaves like a manufacturing line. It requires a supply chain that can sustain millions of sensors, millions of compute modules, and millions of battery packs without breaking. The partnership announced between WeRide and Lenovo is not just about integrating software. It is about leveraging Lenovo's high-performance computing infrastructure to solve the simulation bottleneck. Now consider the simulation bottleneck. To train an autonomous vehicle, you need data. You need to know how to handle a sudden rainstorm, a construction zone, or a pedestrian stepping off a curb. You cannot wait for these events to happen in the real world. You simulate them. But simulating 200,000 vehicles interacting with a city requires massive computational power. This is where the collaboration with Lenovo becomes critical. They are deploying their HPC 3.0 platform. This is high-performance computing infrastructure designed to handle the load. It combines physical fleet data with generative artificial intelligence. This allows the system to learn from simulated scenarios that have never occurred in reality, creating a synthetic training ground that accelerates long-horizon manipulation. This is crucial because real-world testing is slow. You cannot crash 200,000 cars to learn from mistakes. The generative AI creates new scenarios on the fly. It teaches the system how to react to edge cases that are rare but critical. This shifts the training paradigm from collecting historical data to generating synthetic data at scale. The simulation becomes a training partner rather than just a testing ground. However, the simulation is only half the battle. The hardware must be ready. We are talking about the NVIDIA DRIVE AGX Thor chips. These are the brains of the operation. They are powerful enough to run the complex neural networks required for Level 4 autonomy. But a Level 4 system means the car drives itself without human intervention. That requires redundancy. It requires that if one chip fails, the system does not crash. Manufacturing these chips at scale is difficult. Lenovo is bringing its manufacturing expertise to the table, but the supply chain for these specific high-end compute modules is tight. Then there is the LiDAR. LiDAR stands for Light Detection and Ranging. It is the sensor that maps the world in 3 dimensions. It sends out laser pulses and measures the time it takes for them to bounce back. This is how the car sees obstacles. To deploy 200,000 units, you need 200,000 LiDAR units. The supply chain for optical components is not as mature as the supply chain for standard electronics. Every unit needs precise calibration. If the alignment is off by a fraction of a millimeter, the vehicle cannot navigate safely. The industrialization of LiDAR production is a massive hurdle. It requires moving from a prototype environment where you hand-assemble sensors to an assembly line where they are mass-produced with consistent quality. And we cannot forget the power source. A robotaxi fleet is essentially a moving data center. Every vehicle is constantly processing terabytes of sensor data. This generates heat. Battery thermal management becomes a critical engineering constraint. If the batteries overheat, you risk safety. If they cool too much, you lose range. In a fleet of 200,000 units, thermal management is not just about the battery pack. It is about the heat generated by the compute modules inside. The system needs to dissipate heat efficiently without adding excessive weight or complexity. This requires a new approach to vehicle architecture. The cooling systems must be integrated into the design from the ground up, not added as an afterthought. This brings us back to the core of the strategy. The target of 200,000 units signals a shift. It signals that autonomous driving is no longer just a technology company's domain. It is a hardware-software supply chain challenge. It requires the industrialization of both vehicle production and data center compute capacity. WeRide brings the autonomy stack and the regulatory footprint in places like Dubai and California. Lenovo brings the manufacturing scale and the computing infrastructure. Together, they aim to accelerate deployment beyond single-city pilots. They are also looking at a hybrid expansion model that pairs global logistics with domestic manufacturing to speed up the rollout. The research suggests there is a knowledge gap regarding the specific statistic of 200,000 units by 2031. While the technical collaboration to enhance autonomous driving hardware is confirmed, the specific scaling target remains an ambitious goal. It requires a level of coordination that has never been attempted in the automotive industry. It is a move from autonomous driving as a software problem to a hardware-software supply chain challenge. The partnership leverages the NVIDIA DRIVE AGX Thor chips to solve the simulation bottleneck. It pairs the logistics of global deployment with domestic manufacturing scale. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.